Here is a question on quadratics that you may want to try and then check your answers from among A, B, C, and D. So all you need to do is to pause the video and make your own attempt. Okay, let's see the solution that I have to propose. We are told that 3x squared plus 5x plus 4 is equal to a into x plus k, all of that squared, plus h. And then we're asked to find the value of h. Okay, so uh, let's look at it carefully. This is a complete quadratic expression, and here we expect this also to be a quadratic expression in terms of x. Okay, so this one is already in complete form. So let's bring out this one by first of all expanding x plus k squared. All right. So we have, so let's do it here. We have a into x plus k plus h. All right. So that means we have a into x multiplied to x squared, x multiplied to k, xk. K multiplied to x is the same thing, xk. K multiplied to k is k squared, and then plus h. Okay, remember a here is multiplied to this expansion, is not multiplied to h. So we put the brackets here and here, not there. So let's open now the bracket. We have a x squared plus, this is xk, so there are two of them. So it just gives us, excuse me, gives us 2axk, then plus ak squared plus h. All right. So, uh, so let's arrange it as a quadratic in terms of x. All right. So this gives us ax squared plus x into 2ak plus ak squared plus h. All right. So that it has the nature of the classic quadratic equation ax squared plus bx plus c. All right. So that with respect to this, our a is a, our b is 2ak, and our c is ak squared plus h. Just like in the left hand side here, our a is 3, our b is 5, and our c is 4. Okay, if we say that this quadratic expression equals this quadratic expression, the condition for equality of any two polynomials is that coefficients of respective terms must be equal. Okay, of course, we already assume, okay, first of all, the first thing is that the variable must be the same for both polynomials. The variable here is x, and the variable here is x, okay? Therefore, if we say that this quadratic equals this quadratic, the only next thing now that we have to check should be what? Corresponding coefficients must be equal. So if that be the case, our a on the left-hand side is 3. That means 3 must be equal to our a on the right-hand side. 3 must be equal to a. Okay, we have taken this term, the x squared term and the x squared term. They must be equal. And then now we go to the x term. The x term on the left-hand side, the coefficient of the x term on the left-hand side is 5. And the coefficient of the x term on the right-hand side is 2ak. All right. Now we'll go to the last. The constant term on the left-hand side is 4. And so it should be equal to the constant on the right-hand side, which is ak squared plus h. All right. So we have these three information here, which should be able to help us to find the value of h. If a is 3, it therefore means that if we put in the second equation here, we're going to have If we put the second equation there, we're going to have 5 is equal to 2 multiplied to 3k. That means 5 is equal to 6k, which therefore means that k should be equal to 5 all over 6. All right. Now we know the value of a and we know the value of k. All right. So can we now put it in the last equation here so we can get the value of h? We know a and we know k. So we have 4 is equal to our a is 3. Our a is 3 multiplied to k squared. This is our k. K squared becomes 5 all over 6 squared, then plus h. You now see that the only unknown is h. We are now going to be able to solve for the value of h. So this means 4 equals 5 squared is 25. So we have 3 into 25 all over 6 squared is 36 plus h. But 3 here, 1, 3 there, 12. Okay, so we have 4 is equal to 25 all over 12 plus h. All right, let's write that one again up here. Let's write this last equation up there. 4 equals 25 all over 12 plus h. All right, so now remember we're looking for h, so all we need to do is to carry this 25 on 12 to the left hand side. It is positive here. If we take it to the left hand side, it will become negative. So we'll have 4 minus 25 all over 12 will give us h. This is a fraction. We can always make this one also to be a fraction by simply dividing by 1. And so we now look for the LCM of 1 and 12. It is 12. 12 divided by 1 is 12. Multiplied to 4 is 48. 12 divided by itself is 1. Multiplied to 25 is 25. That gives us h. So 48 minus 25. 48 minus 25, that gives us 13. No, pay attention. 8 minus 5 is 3. And then 4 minus 2 is 2. All over 12 is equal to h. The value of h is 23 all over 12. And which of the options there is correct? The option D, 23 all over 12. So our answer is the option D.